Hey everyone, this is the key for your 4.1, 4.2 worksheet. All right, so we have some definitions up here, just a reminder of what we're talking about. So for this first one, we have to study the eating habits of students in Spokane Community College, 40 randomly selected students. So bam, this is our total. And were surveyed to determine the number of times that they purchased food at the school cafeteria during the last week. The following results were obtained. So what is the population of the study, right? What is the group that we are focusing on? So we are focusing on students at Spokane Community College. All right. What is the sample of this study? Well, these are the 4 people that we randomly surveyed. So 40 students surveyed. Okay, the smaller group, obviously there's not only 40 students at SCC, but we're only going to use 40 to kind of give us an example of the general population. All right, organize the data by creating a frequency distribution. So here we go. I'm going to have the number of meals. What is this? Oh, purchased food. Number of times they purchased food. Purchased food, I guess, ish. Number of times someone purchases food at the school cafeteria. And then we have the frequency. And then I'm even going to add a relative frequency. Okay. All right, and we are ready to begin. So the number that we could, first I'm going to take a quick glance, see the numbers 0 through 7, which is, I guess, the number of times per week. So I'm going to just write that in here, 0, 1, 2, 3, 4, 5, 6, 7. Oh no, kind of falling off the page. This is a little sketchy, but we'll smush it on in there. And then we're going to count up the number in each section of this here. So for 0, we've got, I'm going to cross out as I go, 1, 2, 3, 4, 5, 6, 7 zeros on here. So then that would be, my relative frequency would be 7 divided by 40, which is, 7 divided by 40 is 0.175. All right, next. I got to count up all my ones. So I got 1, 2, 3, 4. So 4 out of 40, that is 1/10, which I believe is 0.1. Oh, good. 0.10, right? Twos. Any twos, so 0, 0%. All right. Frequency of threes, so we've got 1, 2, 3, 4, 5, 5 threes. 3 divided by 40 is 0. Wait, oops, sorry, I needed 5 divided by 40. Whoops, not that 3. 5 divided by 40 is 0.125. Great. For 4, I've got 1, 2, 3, 4, 5, 6, 7, 8. So 8 divided by 40 is 0.2. All right, now the fives, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 out of 40 is 0.3. Sixes, got no sixes on there. And then sevens, 1, 2, 3, 4, right, I think that's it. 4 out of 40, which we already had was 0.1. All right, so there is our frequency table, a little smushed, but it's there. And then we're going to construct a pie chart for the data. So this is the number of times purchasing food in the cafeteria. Right, so here I go. Found my center right there. There's my little projector. There you are. Whoa. All right, so I'm going to draw my starting line up this way this time. Okay, so here we go. My first one, oh, I'm going to need to multiply all of these by 360. So these are my degrees. So 0.175 times 360. That is 63 degrees for this one. So here I go. I'm going to mark 63 degrees. And line up this. Oh, 63 degrees. Oh no, which is out here. 1, 2, 3. Put a dot on my table. All right, so this is one meal. Oh wait, sorry, no, this is 0 meals. There we go. Then 0.1 times 360 is 36. This would be 0. So we won't even need that column. 0.125 times 360 is 45. 0.2 times 360 is 72. 0.3 times 360 is 108. And then we have another 0, whoops, and then 0.4 was the 36. Okay. All right, so this was, okay, so next one, 36. So I line this up. 36 would be out here. There's 5, 6. Marking stuff daintily on the table. Okay, that's for one meal. All right, then we had 0 that had 2 meals, 45 that had, or 45 degrees for 3 meals. 45 degrees out here. And this was for 3 meals. Okay, 72 from there. Okay, so this was 0, 1, 2, 3, 4. 4 meals. All right, big one, 108, getting 5 meals a day. So 108, there's 110, 109, 108. Okay, so 5 meals. We didn't have any people that went for 6 meals, but then here's 7. Alrighty, so there is our beautiful little pie chart. And that's it. There you go. So then I'll flip over to the next page. All right, to study the output of a machine that fills boxes with cereal, a quality control engineer weighed 150 boxes of brand X cereal. The frequency distribution in the figure summarizes the findings, and we're going to construct a histogram for the data. All right, so first thing that we can do is I'll kind of draw a little line down here. There's our x-axis where we're going to put our marks of each interval. So we can measure this out too. Actually, do I have a ruler? Oh, hang on, I'm going up to my board. Okay, so using my ruler, I'm gonna have 1, 2, 3, 4, 5 of these. So how long is this? Let's see. I'm gonna shorten this a little bit. I don't want to be on this in here. I guess I could. Here we go. And go straight up here. Here. All right, here's my histogram. Okay, so every centimeter I'm going to put a little tally. These are going to be my intervals here. Okay, so we've got 15.3 to 15.6. This is ounces. And then we have 15.9, 15. Oh, sorry, 16.2, 16.8. Weird. Actually, I'm going to continue to count by threes. This is 0.5 and then 16.8. Okay. So I need, because these are different sized increases, I suppose, we're going to need to make this a little bit fancier. So it's a good thing I cut that short, because we're going to need some extra columns here, because these are not changing by the same amount each time. So we're going to need to consider density when we do this histogram. But the first thing we need to calculate is our relative frequency. So we can add that right now. Here's relative frequency. Okay. Actually, sorry, I should say class frequency. So that's here's our relative frequency already in this column, frequency. And then we want the class frequency, which is where we divide by the total. And then we need the relative width of the interval. And so then we need the density. Okay, so first thing that we do for this class frequency is we divide our relative frequency by our total. So let's get our total number. Oh, actually, our total number of boxes was 150. So 10 divided by 150 is going to be here. 10 divided by 150 is 0.066 whatever repeating, which is about, I'm going to say 7%. Okay, then we got 25 divided by 150. That is 0.16 repeating, which I'm going to say is 17%. Okay, next one we have 85 divided by 150, which is going to be 0.56 repeating, which I'm going to say is 57%. And honestly, this needs to add to 100. So we've got 7 plus 17 plus 57, that's 81, and 100 minus 81 is 19, so this should be pretty close to 19. Let's double check. 31 divided by 150 is, yeah, 21, but we rounded up here, so I'm going to say, this is 19. This is not perfect, but we'll keep it at 100% there. Okay, relative width. So the relative width, we would go from, how do we get from here to here? So this is by 0.3, from 15.3 to 15.6, and then another 0.3, and then another 0.3, and then this one is 0.6. All right, so then our density, final part, is we take this class frequency divided by the relative frequency. So here I go. I'm going to just do this here in front of you, and I'm going to do exact values. So we had 10 divided by 150 for the class frequency, and then I'm going to divide by 0.3. Okay, so this density is 0.22 repeating. There we go. Next one, we had 25 divided by 150 divided by 0.3. So 0.55 repeating. Then we have, let's see, 85 divided by 150 divided by 0.3 is, except we should have another greater one. Hold on. 85 divided by 150 divided by 0.3. Weird. Okay. 1.88 repeating. And then 31 divided by 150 divided by my big frequency here is 0.6. So 0.4. Okay. So there we go. There is our density. So very clearly dense in this 15.9 to 16.2 range. And so now we can build a final histogram. So this side, we're going to make our just frequency because we need to, show the little heights of it. The inside is going to be our percent, our class frequency. And then the other side is going to be our density. Actually, in your notes, this was just our relative frequency density, so we can do that here. So we go from 0.22 to 1.9, so I don't know, let's see. We can count, that's basically, let's just say this is 2 up here. So then, what is this? All right, so right in here, this is going to be 1. Okay, so, so for 50 or 15.3 to 15.6, we are going to go up to 0.3, which is right in here. Right here, how about? Okay, there's our box, and then I'm going to put my percentage here. This is 17%. Okay, then we had, oh, sorry, 7%. 7%, this number. Then our next one, our relative density was 0.55, so we're going to go up and over a little bit. All right, this is not perfectly drawn to scale, but that one's 17%. All right, then here's our big one. So this goes up to 1.9. Okay, and so this one is 57%. And then this guy, this whole area only goes up to 3.34, so a little bit higher than this one. Oh, this one should have been at 0.22. Whoops, sorry everybody. Should be a little bit lower, but that's okay. All right, so this is 19%. There you go. So that's a good little histogram that shows the number of cereal boxes for all those different weights. Okay. And the last little bit, we're talking about the mean, median, and mode. So these are kind of a little funky questions, and we'll do another worksheet that kind of practices this too. But so we're going to create a data set containing 8 points that has a mean of 10. So we want the mean to add up, or the average to add up to 10. So really what this is saying is we have some sum of 8 points divided by 8. That needs to be equal to 10. So our sum just has to add up to 80, right? 8 times 10. So here we go. I could do I could do straight tens. That would be a really easy way to do that, but it's kind of however, whatever way you want to do this. If you want to get more creative, I'm honestly just going to make all these 10, 10, 10. So that's 30. Let's say I did 9 and 11. 1, 2, 3, 4, 5. That's 20, 30, 40, 50. Let's say I had 20. So 10, 20, 30, 40, 50, 60, 70. All right, cool. And then let's say I've got 3 and 7. All right, so kind of random, but if I add all these up, it's going to be 80. So 10 plus 10 plus 10 plus 9 plus 11 plus 20 plus 3 plus 7. That's 80 divided by 8 for the 8 data points is equal to our median, or sorry, our mean of 10. So I don't know, however way you want to do this, there's lots of different ways we could do that. But there you go. Then we're going to create a data set of 8 points that have a mean of 10 and a median of 7. All right, so let's see. I could do, I need some like low ones and some high ones. So let's say we've got like 1 and 19. Okay, so there's 20 right there. I could do my mean of this, so the location of the median is going to be at 8 plus 1 divided by 2, so that's going to be at, whoops, I'm doing that in my head, sorry, the fourth and a half number. So these two in the middle need to have a middle ground of 7. So they need to be like 8 and, or sorry, 6 and 8. Because when it splits the data, we take the middle of those. So let's say that our two middle numbers are 6 and 8, so that our median is 7. All right, so let's see what I've got. 1 plus 19, that is 20. Let's say I put a 12 in here. That would get 8 plus 12 is another 20. I could do a 14. That's another 20. So 20 plus 20 plus that's 60. Okay. And so now I need to add to another 20. So I could do, let's see. I mean, yeah, that's fine. So let's do 6. Oh, sorry, I'm just thinking through this. What do I want to do here? 2 little lower numbers. So these are going to have to increase. I'll do 3 6s, whatever. And so then I'm going to be short 1 plus 6 plus 6 plus 6 plus 8 plus 12 plus 14 plus 19 gets me to 72. So I'm going to add 8 to one of these. Let's say I add it to this last one because now I don't have to change the order. So 19 plus 8 would be 27. Right, so let's try this out. All right, 1 plus 6 plus 6 plus 6 plus 8 plus 12 plus 14 plus 27 is 80. Perfect. So then the mean would be 10 because I would divide by 10. Divide by 8 to get 10. So that's good. And then the median is 7. Again, I would cancel out. These are in order, so cancel off to get to the middle. The median is in between. It's at the 4.5 location. So here's my fourth data point, and then the 0.5 would be between here, which is 7. Phew, that was a little weird to explain, but hopefully you're following me. Then create a data set containing 8 data points that have a mean of 10 and a median of 4. All right, so same idea. We've got 1, 2, 3, 4. In the middle, I got to have a 4, 5, 6, 7, 8. All right, so we've got to have some low numbers here. So let's say I have 0. Let's say I have 1, 2, 3, and 5. So then my median is 4. So then these 3, I got to get to 80. So I got 1 plus 2 plus 3 plus 5. All right, so I've got 11 so far. So then let's say I've got 69 more to cover. So let's say I've got, I don't know, 50. So then I've got 19 left to cover. So let's say I'm just going to do, actually, sorry, 9 and 10. That would be a fine way to do this. 9, 10. Okay, so again, my total is still going to add up to 80 so that I can divide by the 8 data points to get a mean of 10. And the median is still smack dab in the middle here at 4. Okay. Last one. Create a data set containing 8 data points that have a mean of 10, a median of 7, and a mode of 5. So I'm going to kind of do the same thing that I did up here. So I've got 1, and then I'm going to do a whole bunch of 5s because I need a mode of 5. All right, so 1 plus 5 plus 5. So if this is a 5, then my median's got to be 7. So I've got to go 2 more up here, so I got to do a 9. Then the mode would be 7 here. And then we can fill out these next 3 so that we add to 80. Haha. So then, okay, so I've got 1 plus 5 plus 5 plus 5 plus 9. That's 25. I need to get to 80. So I've got 55 more to go, and these could be anything. So I could do 20. I could do well, 20, 35, let's see. Actually, 20's got to be later on. So let's say 10. And then I could do 11. So 10 plus 11 gets me to 21. So 55 minus 21 is 34. Okay, so let's try this out. Median is definitely 7. If I get halfway in between these 8 data points, I'm here between 5 and 9. The middle is 7. All right, now I'm going to add all these up. They should add to 80. 1 plus 5 plus 5 plus 5 plus 9 plus 10 plus 11 plus 34. That is 80. So then I could divide by 8 to get a mean of 10. Check, check. And the mode is 5 because I have 3 5s. So that would be an example of a usable data set, but there could be lots. So just make sure it checks all those boxes on your homework. Last little group, last page. To study the efficiency of its new price scanning equipment, a local supermarket monitored the amount of time its customers had to wait in line. The frequency distribution below summarized the findings. Find the mean of the time spent in line and round the answer to 2 decimal places if necessary. So this is finding a mean with grouped times here. So we don't know like exactly like 2 minutes and 33 seconds. We don't know the specifics. So we have to take the midline of all of these. So I'm going to call this the midline. Midpoint, I guess. Add that to my table. Okay, so halfway between 0 and 1 minute is, I'll stick in minutes, so 0.5 minutes. This would be 1.5 minutes. This would be 2.5 minutes, 3.5 minutes, and 4.5 minutes. Okay, you could do that in seconds if you want. I'm going to just leave it as minutes and see how this goes. So then we multiply the number of customers times our midpoint, and then we're going to add all those up to get our sum on top. The total number of customers is also going to be helpful, so I'm going to add up this column before we start. 78 plus 57 plus 65 plus 43 plus 33. So we have a total of 276. Okay, and so then we are multiplying our median. So these 2 columns basically. 78 times 0.5. That's 39. So 39 total minutes for that first group so far on average. 1.5 times 57. 85.5. 65 times 2.5. 162.5. 3.5 times 43 is 150.5. And 33 times 4.5. Yeah, 143.5. Okay, so then our total here, we'll just call this T for total. I've got 39 plus 85.5 plus 162.5 plus 150.5 plus 148.5. Bam. We get a total of 586. So this is the total time waiting in line. We divide that by the number of customers, 276. So our mean, which we can call X bar, you can get used to that shorthand, was 586 divided by 276, which is 2.123-ish. So we can convert that to seconds. Let's see, we've got 2 minutes for sure. All right, and then 0.12 times 60 seconds, and 7 seconds. On average. So find the mean. Right, so people are waiting about 2 minutes on average in line, which is not terrible, right? There we go. Okay, last little bit. Josh has taken 3 math tests and his average test score is 81%. If the instructor curves the scores on on one of the tests so that Josh's percent just on this test increases from a 78 to an 84, what is his new average test score? Okay, wait. Curves the score on one of the tests. Okay, so he had previously had 3 test scores that averaged to 81. So that's dividing by 3, and it said it used to be a 78, plus we can figure out what the other two are. 81 times 3 needs to add to 243. So that's 165 extra points to work with. Let's say he got a 80 on one. Okay, cool. So this could be, something. Actually, I'm going to just leave it. I'm sorry. I'm going to leave this as 165 for the other 2 tests. It doesn't really matter what the other 2 tests are. We've got 165 points that are going to stay the same. So this is the test that they're going to curve. It was a 78. These are the remaining points that we need to make this statement true. And I did this, okay, what I did here was I multiplied by 3. So 3 times 81 gives us the total number of points we would need. And that was 243. Because 243 divided by 3 is 81, right? That would give us that average. So this number up top needed to be 243 to have an average of 81. So that's what I figured out here. Now I figured out, so these 2 other tests added to 165 points. We're going to curve this one. So we are now going to have 165 from those other 2 tests that stayed the same, plus this one's going to go up to an 84. We're going to divide that by 3. So this is like new. Okay, so 165 plus 84 is 249 divided by 3, which is an 83. So new average, what is the new average test score? New average test score is 83%. Hooray, there it is, bam. And that is the end of your 4.1, 4.2 homework assignment.